All right, so today we're going to be talking about lambdas and build patterns. And lambdas and method, oh, I didn't get to method references, but they're pretty simple to go over. Basically, lambdas and method references let you, let me just go to the next slide. They let you, and I'm quoting the Java tutorials page right now from Oracle, treat functionality as method argument or code as data. And that means you can pass code into a method as an argument, and the method can call that code. You can also reference code. You can change the way that code can be passed around, and they're useful in many scenarios, especially in our case, GUI applications and robotics. They're incredibly useful and make our code a lot smaller and cleaner. So let's take a look real quick at an example of lambdas. So here on the left here, I have a thread without lambdas, okay? And you're probably used to this from last class. So if you remember correctly, in order to create a thread, we had to pass in a runnable, right? Or you directly extend the thread class. In this case, I'm just making an anonymous class, meaning a class that doesn't have a name, just making a runnable class right now. And I'm directly implementing the run method and putting out the code I want, which is just the system.out, right? And this is fine and all, right? But once the code inside the runnable becomes more complicated and whatnot, you can see how there's a lot of extra syntax involved that doesn't actually relate to the code. For example, we say new runnable. Okay, we don't have to know that it's a runnable. We don't have to know that this is overridden, it has to be public void and run. We pretty much actually only care about the code inside the runnable, right? So on the other side with lambdas, we simplify that by just simply putting parentheses, arrows, just the hyphen and the greater than symbol, and then brackets if you're doing multi-line code, and then you're putting your code. So now we only have a few characters of syntax that really say, okay, I'm going to be trying to define some code that I'm going to pass into this constructor for thread here, right? And then really only the code is focused, right? And you can see how this can be useful. If I wanted a thread that just calls one simple method, oh, it looks like ready to join. If we wanted our code, if we wanted to pass into thread one simple method, one simple line and one simple method, you don't even need to have curly brackets. You can contain the entire code into one single line. And that also means you can pass in a method as well. So for example, if I just wanted to be really redundant here, if I wanted to pass in the thread itself or this method itself, I can say this, I'm referencing this current, whichever class this function or this method is put into, right? Double colon and then the name of the function. And then this will give it, and then now, and I don't think you even need this, okay? So now you're just directly passing in this function into the thread. And that's a method reference. Basically, you're referencing a method in the same way that you can pass in a class or pass in an integer or string or whatever, right? So that's a lambda. Okay, they're extremely useful, especially as you start to work with more and more libraries and frameworks that take advantage of the fact you can pass around classes and anonymous classes, and then lambdas will just shorten it and make everything look nice and pretty for you. Okay, and I have a practice later on. Today's going to be a bit of a shorter class because we are approaching the end of our Java curriculum, and we are, well, for me personally, I have a lot of work to do when it comes to my college supplementals. That's been a big pressure for probably a lot of the seniors in the robotics team recently. But we're going to go over build patterns really quickly. And there are two that we're going to talk about today that we see fairly often. And they're used all over. They're not specific to one single application. They're called build pattern for a reason. And probably the most commonly used, or like probably the most well known as well, is a singleton. And singletons are Java classes that can only have one instance, which is where the name singleton comes from. To do this, you have to make a method with a private constructor and a public static method that returns a private instance of that constructor. And what that translates to is basically, so you see here we have a private constructor here, right? Let me get my pointer. This is a class called globals. Okay, let's say this class might store some of our global variables, right? Or manage a global state where the variables will be the same throughout the entire application, no matter where you call it from. You can see here we have a private constructor here, globals integer ID curly brackets. Okay, and the reason why, and because it is private, that means the constructor cannot be called outside of this class, which means no class can ever create another instance of global. Only code within globals can create an instance of it. So now we have another, oh, this one should be, static, I believe. Um, we can have a private static class, okay, called globals instance equal to new globals. So we're already making a static globals instance, okay? And this is perfectly legal because even though the constructor is private, because this declaration is inside the globals class, we are allowed to call it, okay? And all we have to do now is we just make a static method called globals get instance, and we can turn an instance. So if you ever need to access whatever member variables and methods that globals provides, all you have to do is instead of saying new globals parentheses and whatnot, all you have to do is says globals dot get instance and then dot whatever you want to do with the globals. So this ensures that you only ever have one single instance of this at a time. And this is really useful if you're managing the state of your application. For example, if there's a variable that you're constantly updating, but all the code, no matter where the code is, has to share that same variable, you can store it in the globals class. If you're like doing a specific process where, like, for example, you're making a for example, you can only have one subsystem of a type on a robot. That's maybe when you want to do a singleton. And just having the private constructor in the get instance reinforces the idea, and it prevents anybody from accidentally making another instance. It really is there for the programmer, not necessarily for the execution of the code, but for the programmer. And then there's another pattern that you sometimes see. It's called the builder pattern. And it's a builder class that accompanies another class. It's usually and that's usually a data class, a class that just stores data. And it has methods that builds the class for you. And what do I mean by that? The builder pattern basically means if you have a class, I'm going to provide you some extra tools, some basically syntax sugar in a sense, to try to make the really streamlined process. And technically, there's a lot you can do with a builder pattern, for example. So let's go ahead and take a look at the code in REPL. I'm just going to go ahead and share my screen. All right. And I'm going to go ahead and zoom in a little bit just to make sure you guys can all see it. So here, this is the lambda practice that we'll be doing later, but let me go to the builder pattern example. Okay. So this is the data class that we are mostly focused on. Oh, I feel like I sped through it. Is anybody confused about anything so far? Lambdas and the singletons. If you guys are good, can you use the green check mark in the participants menu just to make sure that I'm not going too far ahead? I only have 2 check marks. So what about a no if you don't really understand anything? Okay. All right, can you guys say in chat what you guys are confused about right now? Just to give me a general idea, and I'll go back and explain it again, because I think I went through it kind of quick. Okay. Anything else, or do you guys all agree with Yash? Okay, I'm just gonna go over everything a little bit slower then. All right, so I had this example of a thread, right? And the idea is that whenever you need to pass an anonymous class, okay, so you're just creating a class, but you're not assigning it a name. It's kind of like a throwaway class. It's a class you make on the spot just for the purpose of like using its methods or whatever. In this case, realistically, when we're creating a thread and we're passing in an anonymous runnable, right? We're not really caring about the runnable, the fact that it's a class. The thing that we actually care about when we pass a runnable into pred is the fact that the runnable lets you put code inside unless you pass in code into Fred, right? Fred can use the code in Runnable. But the thing is, we have all of this extra stuff here. Like we don't need to care about the new override public void run, because we only care about the code. So lambdas give us a way to really shorten and compact our code, and then to make it just as simple as putting two parentheses. If the method has any arguments, you put your parameters in there, an arrow sign, curly brackets, and the code you care about. Okay, so I'll go ahead and open up
Samuel, can I
until.
jump in?
Yeah.
I think that it's not really explained in the slides here, but you can kind of think of lambdas as a way to pass, and the way we use it most is to pass a method as an argument for a constructor or another method's parameters. So what you would do in those instances is you're gonna you can use the I think you might have a sort of example on the next. Go to the next slide, Samuel. So you can kind of think of this as being just what Samuel's highlighting right now. You can kind of think of that as being a reference to the print line. It's kind of a no, Samuel, go back.
What's this?
Yeah. You can kind of think of that as a reference to the print line method within system.out, and then you can pass in your parameters that way. So it's kind of a way to like take a method as a parameter to a constructor or another method, and you take it as a runnable. Then the other way to do it is by using the method reference, which is the this or whatever class contains the method, and then 2 colons, and then whatever the method's name is. But that only works for methods without parameters.
Oh,
And that would
actually,
print out an empty line, maybe.
yeah, exactly. So, so basically, and Grady's read about that. You pass in a method, and that is the exact definition of a lambda. Okay, but if it's easier for you to think about, it's nice to think about that you're passing in the code of the method or whatever. But realistically, you are passing in the method. But let me think. There was something about lambdas. Um, there's some very complicated use cases of lambdas. For example, like when we say this lambda, okay, and this is referencing this method, right? This is pointing towards that method. The funny thing about this is that the thread expects a runnable class, right? So Java automatically sees that runnable has exactly one method, and is actually one method that has no parameters, and it will automatically implement runnable for you. So in a sense, if you want to use method references, you also have to make sure that the thread kind of, or the not the thread, the method or the constructor that is accepting the method reference, the class type only has one method. There's a bunch of complicated stuff, but in general, this is the furthest extent you're gonna ever end up gonna be using lambdas. And I want to jump in IntelliJ real quick just to kind of show you guys um, some examples of this. So here we go. New share. Okay, can you guys? I should be sharing my IntelliJ now. Okay, and this is the same deal here. I have two versions of the Fred Lambda example. Okay, so I'm gonna go ahead and say here, I'm gonna go ahead and make another interface. Okay, and my lambda, I'm gonna make a method that accepts this interface, and then it's gonna run a method inside the interface. But I'm gonna pass in a lambda. So let's go and type this out and just show it. Go full screen. So I'm gonna call this interface. I'm just gonna say my code, and then and then I'm gonna give it a method. So I'm gonna say public void some method, and I can go ahead and give it some parameters. So for example, I'm gonna just go and pass in a string, okay? And then because it's an interface, I'm not gonna define the body of the method, so I'm done here, okay? And then I'm gonna go ahead and make a method that adds a string or that will print out or sorry, that will call some method. Okay, so I'm gonna go ahead and do this. Let's see, let's do void call some method. Okay, and I'm gonna accept my code. So and my code. So what's going on here is this method is gonna accept a class and a class type. In this case, anything that implements my code, this interface here. And then I can say my code dot some method, right? Because it's part of the method declaration. And then I'm gonna go ahead and pass in a string. So for example, ASDF, okay? And we're gonna go ahead and call this method public static void main string args, and we're gonna go ahead and use a lambda for this. And we're not gonna be the classic way would be to we're gonna say call some method. I need to make this static. That's right. We're gonna do call some method, and we're gonna say new my code, and we're gonna implement it on the spot, right? And we can say system.out.println. This is my code, and then let's add the string. Okay, so I'm doing something with the parameter as well, but we can go ahead and shorten this into a lambda, and IntelliJ will actually tell you if you can potentially turn into a lambda. So you can see here that this declaration here is actually grayed out. Same with this runnable down here, actually. If you hover over it, I know the text is really small, but it says anonymous new my code can be replaced with a lambda, and there's a button that lets you replace with a lambda, and it'll automatically do it for you. So you can see here, because I am implementing my code with the lambda, it's gonna automatically see, okay, I've got one method here, some method, and then it's gonna say, okay, I have a parameter string s. I'm gonna go ahead and put that down here before the arrow. So this is now the parameters, okay, of the method, arrow sign, and then your code, which is system.out.println. This is my code, and if I ran this, what do you guys think this code would produce in the console? Can you guys say if you guys know, can you guys say in the chat box? So I'm calling some method. I'm creating a lambda, okay, s, and then I'm gonna say, and the method has system.out.println. This is my code plus s. Now when I do call some method, I'm passing ASDF. What do you guys think will be printed out to console if I were to run this code? Yeah, that's right. This is my code ASDF. Okay. So and then technically you can also go ahead and pass in a method reference. So let's go ahead and do that now. So I'm gonna say I'm kind of running out of names here. I'm just gonna say foo for now. And it's gonna have to match the type of this, okay? But I'm gonna do the same thing here. So out.println. This is my code plus s, okay? And then if you don't want to have, especially when you get into more complicated projects, if you don't want to have a bunch of code clutter into one main function, you can separate it out into another function, and you can use a method reference instead of a lambda. So you can say this. So when I say this, I'm going to be referencing a thread lambda example here, right? Double colon foo. Okay, and let's see what the issue is here. Okay, like I just said, thread lambda example then. So now I am directly referencing the class name, and I'm saying, okay, call this static method foo. Okay, and if we're doing a member function, you can just go ahead and type this. But because we're all dealing with static right now, just call the thread the class, and this will do the exact same as the code before. So now we're passing in the method reference. So basically, when we say call some method, it's gonna receive my code, but this method now directly implements some method in my code here. And then, so basically, you can see how the lambdas or the whole deal with lambdas and method references and whatnot is kind of like, quote, intelligently trying to work some things out for you. But in general, now this method is being called, and we can pass it in as an argument. Key thing, we can pass this in as an argument. Okay, so does this make sense to everybody now? The idea of lambdas and method references. Yes or no? Okay, great, fantastic. All right, I'm assuming you guys will also have some questions about singletons. I don't really want to go over build patterns too much because really, it's one of those things you really learn how it works by working with them, and it's kind of hard to make a practice for these things. But basically, a singleton, you'll only ever have one instance of this. So, for example, I'm just gonna make a quick mock-up class. Okay. Let me set this up. Okay, share screen, IntelliJ. There you go. So I copy and pasted the singleton here. The singleton here is globals. Okay, I'm gonna go ahead and make a public static void main string rx. So I'm gonna go ahead and try to make an instance of my globals. What do you guys will think will happen if I try to make an instance of globals? Does anybody have any sort of idea of what might happen? You guys say in the chat. Okay, somebody's just getting an error. Right, exactly. So we're gonna get a compile error. The code's not even gonna let me compile. So if I try to say new globals, you'll see here that IntelliJ is already complaining and just says globals has private access in globals, and that means I cannot make an instance of globals. Well, how do I get it? I say globals dot, and I'm gonna call the static method get instance, and now I have my instance of globals, and I can do whatever I want. I can say toString blah 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 blah, you know. So this is how a singleton instance works, because we're always, in order to get an instance of globals, you always have to call get instance, and get instance will always return the same instance of globals every time. This is now effectively a singleton. There's only going to ever be one instance of globals that ever exists. Okay, make sense? Yes or no? Make sense? Okay, I got a thumbs up. I only have two people who said, oh, okay. All right. I think that's enough. All right. And we're going to go ahead and take a look at build patterns now. Okay. This one's a little bit of a chunky one. This is not the right window. Okay. Let's. So many Java things on my screen now. Where is the REPL? Ah, here's the REPL. Okay. Share screen and then REPL. All right. Do you guys need the link to the REPL again? I'll go and send in the chat, just so you guys don't have to fumble about looking for it. Kind of hard to send things in chat when the chat menu was hidden. There you go. All right, here's the REPL if you guys want the quick link to it. But you guys can take a look at the Zoom screen share for now. So what we're really caring about right now is this class here in the middle. It's called class circle, and it basically holds some variables, right? We have the integer radius, integer center x, integer center y, and then we have a constructor that constructed with radius, center x, and center y, right? So this is a very basic function, or sorry, not a function, a very basic data class. Now this giant section of code here is the builder, okay? Let me zoom out a little bit just so I can see a bit more. So the builder here is going to hold the same variables, right? Except it's not going to have, I mean, for now, it's not going to have a constructor. And the idea is, in order to set the values of the radius, center x, and center y, you do set radius, center x, and center y as methods instead, and then we change it. And the most key important thing is you return this. So I'm returning the instance itself, which means you can chain method calls one after another. It'll look really cool after I show you guys. And then finally, at the very end, you can call build, and then it'll actually make the instance a circle, pass in all the arguments and whatnot, and then you'll get your product. It builds a circle, essentially. And right now what I have, we're not really doing anything with the arguments. It's pretty much just a glorified constructor. But say, for example, set radius, you want to take in diameter instead, right? And then radius divided by 2. So now you've made it so you can actually change or do some sort of process and then create a builder based on that. Okay, and that means every single time if I had the diameter, but I have to give the circle the radius, well, if I'm calling the builder, I can just directly pass in the diameter and I'll automatically convert the diameter to a radius for me. And that's what's nice about the builder. It lets you do stuff with the variables and really cleans up the process if an instance has a bunch of variables, has a bunch of stuff that requires to be set beforehand. Okay, let's go and take a look how to use this because I think it looks very elegant. So I'm going to be making a variable circle, and then I need to declare and assign a instance to it, right? So I have new circle builder here. So instead of creating a circle, instead of calling new circle, I say new circle builder and say dot set center x, dot set center y, dot set radius. That also means it's a method, I can move this around. And the reason you can change methods like this is because these set methods, they return the circle builder by itself and they return this. So when I call this method, it returns the circle builder, right? It returns the circle builder. So I can just call dot set radius again. This one returns circle builder again, and I can just call dot center y again. So if you want to be able to chain methods, you have to return this. You have to return itself, like I have set here. Okay. And then finally, in the very end, because I got the free main variable set already, right? I can call dot build. Dot build doesn't return circle builder, it returns circle. So dot build is going to take in all the information I put into the methods beforehand, and it's going to make a circle for me. And that's a circle builder. When we, I don't think we're using that in robot code in the moment, but if you've ever worked with Android, builders do exist. Libraries, many libraries also do use the builder build pattern, and even some Java built-in libraries use builder as the main way to construct instances. It's a really nice and clean way to initialize instances that require like a lot of information. Okay, but that's the builder. I don't want you guys to stress too much about these build patterns right now because again, they kind of come from experience, and you'll understand the more you see and use them yourself, okay, from other libraries. And that concludes the lecture for now. That's just the builder pattern. I don't really have too much to say about it. So I've got a simple little practice for you guys to do, okay? And it's going to be a lambda practice. I'm going to send the direct link to the file in the REPL. But basically, go to the practices folder and go into lambda practice.java. And then you can see here, I have some methods here, okay? Or some classes here. I have a class, which is lambda practice. It just holds my main method, okay? It has like, and I have an interface called sorting method. It has one method called compare, and it does something with A and B. And then I have this class sort array that has a static method. It takes in a list and a sorting method. It will do some fancy sorting stuff with the method, calling it and whatnot, and return the list. So I want you guys to go ahead in the main function here where I'm highlighting. I want you guys to go ahead and convert this to use a lambda instead of using an anonymous class declaration. Okay, I want you guys to give that a shot. So go ahead and copy this file into your own respective folders. Make a new file called lambda practice.java, and then go for it. If you guys need help, me and Grady are here. And when you guys are done, use the green check mark, and then we'll come and check out your code.